Hello everybody, my name is Daniel German. I'm professor of computer science at the University of Victoria, and I have been teaching programming for more than 10 years. And so I want to tell you today about how I have been using Emacs effectively during the last 10 years and to try to improve how I not only create content for my students, but also how I deliver it. And particularly how within the last 5 years I have been using org mode in a very effective way, and that I think that benefits both my students and myself in the creation and the delivery of content. Let me switch to my computer, and I'm going to remove myself because I can use all the real estate screen. And so the goal of my presentation today is really to give you a little bit of an overview of how I have been able to combine the use of org mode and with some other tools. I'll talk about specifically about them, and then also offer some suggestions and recommendations in how to get started. And I have created a configuration, a set of configuration files that you can use. I will describe them towards the end, and so hopefully it will make it easy for all of you to get started on using it. And so let me start talking a little bit about the challenges of teaching programming. I think that the fundamental one is that keeping the content and the slides up to date is hard, because the content is programs. They are programs that sometimes have errors, and sometimes the slides are incomplete snippets of code, and that once they go into this slides software like Google Slides or PowerPoint, they're essentially static objects. And and if we need to update them, we basically don't know whether the update code actually works or doesn't work. And also we cannot insert automatically the output. We'll have to run the snippet outside and run it and then insert that code. So that's very cumbersome. It's really one of the major challenges of using a slide software to teach programming. The other thing is that during the presentation, there's nothing you can do with the code. You might be able to edit it, but you cannot run it. You have to move outside of the presentation software to be able to execute the code. And the last one is kind of related to the previous two, is that you don't have a single file, and your information is spread across many different files. Especially if you have lots of different snippets in your slides, you probably have a lot of different small files, each of them contributing something to your slides. And so it becomes a pain to manage. And so all of this is where org mode really excels. And org mode is capable of doing everything. And it needs a little bit of help from some friends. I will describe what I mean by that. And but the other thing that is also very valuable is that it's within the magic of Emacs. I absolutely love to be able to work with text within Emacs, and I enjoy actually creating my notes in org mode way more than if I was making them in Google Slides. Let me start by giving you a short demo. And I have been teaching programming in C++ for around 5 years. And this was really the trigger towards trying to do everything within org mode. And so I have a repository and in GitHub. And I think that GitHub is an excellent tool that works in collaboration with org mode. And I'll describe actually what I mean by that. So my lectures are essentially org files, and so for example, let's go into one of these files. This is an org file. You can actually see it in the extension, and I get a table of contents. GitHub creates or gives us actually the ability to quickly jump, and it creates a dynamic table of contents, but also can actually create it automatically. And then here it goes, and this is the code that I have. This is a snippet of my that I present in the class, and so let me actually show you how I do it within Emacs. And so what I will do is the following, and let me try to open that file. And so here's the file, And it's exactly the same that we were browsing in GitHub. And what I do is I simply just scroll through the document. It's almost like movie title, movie credits at the end of the movie. I don't break them into chunks that show in the screen. I see no point in doing that. What I do is I simply scroll through the text. The students are able to see the same information in GitHub on their computer, or they can print it if they want. And they are able to actually follow with me and then having a much bigger picture than if I just show a very small snippet. In the case that the snippet is too big, and so for example, let's say this one actually doesn't cover covers more than the full screen, I'm actually reduce the size and then give a little bit of an explanation of the whole thing, and then focus and say, this is the line where we have to pay attention. And notice actually how I use color for that. I think that the ability to use color and typesetting is fundamental to be able to do this effectively. And the nice thing is that we can configure org mode to be able to do most of this automatically. As I said before, one of the great advantages is that I can actually run the code and dynamically. So let's say that the student says, but what if I change that value to 10? Well, let's try it. Let's change it, run it. And then you can see here that it has a 10. So that's really powerful because you're not tied to what is the content you have on the slides. If you find an error that or an omission, or you want to talk about something else, you can very quickly do it. And you can add comments and then make some suggestions specifically to that. Or worst case scenario, if you really, really need it, and you can say, let's load it into Sornov. Let's actually do some hand annotation. Let's actually say, oh, look at this 10. This is the value that I want you to concentrate. It's not perfect. I'm not doing it within Emacs. I wish there was a way to do it, but it is absolutely effective because I'm actually able to use the power. And notice that all that they exported is just the block, and also it did the color and typesetting. The typesetting of the content. So this is actually great. I have the colors, red, purple, etc., etc. So I love be able to do that. And this is just a temporary file. I can actually discard it, and it doesn't really matter. Let me go back to the presentation. And so that's the delivery. So the delivery is great, and I can tell the students now that you're actually in GitHub. If you want to test the code, just cut and paste. And notice that I click on the little icon. Now it's copied. It's now part of the kill buffer. So if I want to actually create a file that has that content, I can very quickly do it. Try that with PowerPoint. You will have to have the text without any nice typesetting, or you will have to have a picture that is impossible to cut and paste. So that's something that the students really, really appreciate of this. And they can try it on their computer. They can load it into their favorite editor. And I don't force them to use Emacs. But I have to say that some of them really get intrigued by this power, that they want to try Emacs because they see that they can do that I can do things that they cannot do with other tools. Okay, so let's go back to the presentation. The other half of it is preparing the notes. And I think that preparing the notes is something that I want to do as easy as possible. I want to be able to reduce the time that I waste on things that they're done. They're not part of the actual thinking or the delivery of the presentation. So let me create a file, and so let's call it read2.org, and well, I have this one, so let's call it read.org. Oh, I have this one too, so let's call it read4.org. So it's empty. I use just snippets. I think just snippets are very important, and I'll go through this in a little bit later. It's important to set up the properties for each language that I use properly. I'll describe this a little bit later. Unfortunately, the properties have to be evaluated one at a time, and so I'll just going to kill the buffer and open it again. So now all of these properties are properly set. So as I said before, I have some snippets, so I can actually do very quickly. So also this is C++, C out, hello world, std, and L. and then I run it, and then it's inserted down here. So nothing special. And let's assume that I make a mistake and I type double L here. I will get an error, and these line numbers unfortunately don't perfectly match with the line numbers in the little snippet, because there's some code that Babel inserts that shifts them. So that's something to be aware of. And so I can correct it, run it, and then it inserts the result. Let's do one in C. I'll explain the exports both a little bit. So let's assume that I don't want to have a full main program. So let's assume that I just want to demonstrate how to use printf. Hello world %s / my friend. Let's run it. I get a bunch of errors. Why? Because I don't have a main program. So I have to actually tell Babel that I want a main program. So yes, put a main around it. So now I run it and it says, oh, in the function main, we have an implicit declaration for function printf. I'm very, very stringent on my compilation option. So I want to have every single potential error displayed. So that's actually why. So in this case, actually need includes. So I can say includes stdio.h. And now run it and it runs perfectly. So why is this important? Well, it allows me to just have the snippet that I'm concerned about. I don't have to have all the overhead of having to have the include, main, etc. If I want to show just one specific concept and I can do it in very few lines of code, I can do that immediately. Of course, the students will not be able to cut and paste it without the main file, but that's something that we can explain then. We can do all the languages, so I can say print, let's print just a list. And or let's actually keep updating it, and let's do a map and of a lambda x multiplied by x, and then we run it. Okay. The thing that is important is that if we also have the full power of the environment, right? So we can actually edit it in the native mode of the language, and wherever we actually want to use specific features that they are available in the particular mode. And but for most of the cases, I don't need that because my examples are relatively simple. And let's do one more. And this is a little bit different, SQLite. In the previous examples, the output that is inserted is a standard output. In SQLite, I want to actually see the tables. I want to see how the tables, what the results are. And so let's create table S. Let's call it R, A int, B int, and let's run it. It says, oh, the table already exists. Okay, so drop table if exists R, and then we run it. Okay, so now it's created. SQLite. So we can say create table. Let's actually add SQL, and here we're actually going to add. This is an example in C, and here we're going to have C++. Okay. Okay, so SQL, and then we create a table, and then we populate it, and then insert into our values 1.2, 2.3, 3.4. Okay, so now I have a table, I have values, and I can do select star from R, and then I get the result. Okay, it's almost magic because I can actually get formatted the output in the way that I expected. And obviously, if my result is too big, then it will basically just create a huge buffer, or we'll say the output is too big. So often with databases, I actually narrow my output, right? Or I might do it with a clause where a bigger than 1. Okay. So if the language is supported by Babel, then you can do all of this. Let me go back to the presentation. I'm running out of time. And so let me give you a short tour of how this is done. And I have created a repository, and that shows, so that has all the configuration that I have. Everything is self-contained. You can just download it and run it, and you will have to replace your .emacs.d directory, and then you can explore it, test it, and then pick things out of it, choose, etc. Okay. Let me go through the README, and I think that the README is actually useful. I have a function called lecture start. That is the one that creates indentation, sets up the mode, etc. Let me talk about GitHub. So GitHub is a great resource. Why? Well, it's publishing. As I mentioned before, it's very simple to publish. You basically just push your changes and it automatically renders the code. And it's something that is quite useful. And but it is not perfect, and it's not able to understand the full org. And but for most of the things that I use for teaching, it's sufficiently good. It would be better if it was full compliance, but it's not bad as it is. Version control. I think it is extremely valuable to have version control. It allows me to actually use different computers or keep track of my changes, collaborate with authors, even have pull requests from the students. They actually, it's very empowering for the students. Navigation links, cut and paste between blocks. You can even edit in place if you want to, and if in a pinch you can actually use GitHub to do the editing of your file. Of course, it will not update your buffers. Exports both. This is very important. If we have a block, by default, GitHub will not typeset that the output of that block. It will only put the source code, but not its output. So in this case, if I actually show this in GitHub, hello world will not appear. So what we need to do is, for every block, we have to do exports both. Okay, that's unfortunate, but we can deal with that. And then once it's done, then the output is actually typeset. I mentioned that header args are very important, and because those are the ones that set the parameters for each one of the blocks that you have. You don't want to have to type every single one of them at once. And so, for example, let me go back to my presentation. And so here's actually the parameters for C. And C, I say, I don't want you to automatically add a main. I want to provide my main, and these are the flags to the compiler. With C++, almost similar. With SQLite, I said this is my database. This is the file where the database lives. And for the results, I want you to insert the column names. I want to see the names of the columns in the result. So those actually why the headers are important. There's one in general that is results output. If you're interested on showing the standard output of your snippet, then you have to use results output. Otherwise, it will insert the result of the last expression. It just depends on what you want to show, but it's important that you are aware of that. I'm almost running out of time, so there are some things that they're C specific and that I sort of covered during the demo. You can use advanced org features, and like you can actually use no web. That's confusing for students, so I will suggest that you actually do it, but then inform the students very clearly of that. Some potential issues. Underscore is used everywhere. So by default, it will try to export it, or will try to export it as circumflex, the same as with GitHub. So we want to inform org and GitHub not to do anything with them, and this is via the circumflex. So we said in option circumflex nil, and that actually takes care of the circumflex and also the underscore. It's kind of confusing because it's both, but it's actually named after the circumflex. The pipe character is one of those characters that is actually very, very common in programming, but if you put it in a table, there's no way to do it. Like I wished I had this table nicely where I can say pipe here, but if I put this pipe, it will actually interpret it as the separator. So that's one of the few things that is kind of annoying. So final words, see my configuration file, and try to typeset the code, the buffer as close as possible to what you want to present. As you can see here, I'm actually using colors to highlight. I'm using the current line, and use the snippets. They're amazing, and they will actually make your life much more useful. and experiment. And just a conclusion. So org mode and Emacs really make a wonderful, amazing environment for teaching programming. And I just want to end by saying that I'm very grateful to all the Emacs community, because I have benefited tremendously over the years. I have been using Emacs since 1991. So this is essentially my 30th year that I have been using Emacs. And I think that this is the most important, most fundamental tool that I use day to day. From reading email to doing my teaching, doing my papers, my research, it's everything. So thank you all. And I hope that you find this useful.